give 1 minute leeway. So 5-minute break. talent show, as you know, on the Friday. If you want to be involved in that, then you are going to have to do an audition on Thursday at the beginning of our break. So I think that's roughly about 3 o'clock. But if you want to be involved in that, you need to sign up either by letting myself know or Pastor Warhurst. Pastor Steve Warhurst is standing at the back right now. So let one of us know, and we will sign you up for the auditions on Thursday. Secondly, if you've brought balloons for the water balloon fight, then they need to be filled today. And so, again, that's at the beginning of the afternoon break. And so, if you brought your balloons, then see Gabriel Mitchell. Where is Gabriel? Gabriel Mitchell? He's gone. I don't know what he looks like either. Gabriel Mitchell? Oh, he was sitting there? Okay. Well, anyway, whatever he looks like, Gabriel Mitchell is your man to see if you have water balloons. Disappointingly, we're unable to use the basketball court. That's not available during this afternoon. But if you want to, Frisbee golf is available. So if you want to be involved with Frisbee golf, you can do that instead. Any questions or comments about those announcements? Yes.
What if we didn't bring water balloons?
We do have some extra water balloons as well. So yeah, you're not altogether excluded. Okay, let me introduce our next speaker. Our next speaker is Danny Faulkner. He holds an MS in physics from Clemson University and an MA and PhD in astronomy from Indiana University, and has taught at the University of South Carolina, Lancaster, for over 26 years. He currently serves as editor of the Croatian Research Society Quarterly and has published over 100 papers in various journals. He now works as a researcher, author, and speaker for Answers in Genesis. So he is brainy. Let's welcome Danny Faulkner to come and speak to us.
Good morning. I'm delighted to be back here. I spoke at the conference 4 years ago, and I must confess I didn't know what to expect when I came, because teenagers, they can be a pretty lethargic, uninterested bunch, in fact, disinterested bunch. And so I wasn't expecting much, but I was blown away pretty quickly. What I found was the young people here are very enthusiastic, very excited, and they really get it. They're into deep ideas, worldview ideas, and I'd never encountered such a dedicated, involved group of young people. So the bar's been set pretty high for you folks. All right, you've got to meet my expectations once again. I think the thing that really impressed me most last time was, as I came in and you all were singing, and particularly the young men, when you're teenagers, it's very difficult to get them to sing. I think part of the problem is what puberty does to our voices. I remember that time. It was a very awkward time. You're talking like that all the time, and you're trying to sing in church, and you start to sing the normal songs you've sung, and all just 1 week's time. Oh, that's too high for you, and then the next week it's too low. It's just a bad time, and of course when you're teenagers, it's all about what other people think of you, isn't it? Trust me, folks, I don't care at my age. I really don't. But it's not important anymore. But when you're a teenager, it really is. And so it's really tough on the young men. So I was really impressed. Not the women, it's okay. Their voices don't change much in puberty. But the young men, they were singing and singing parts. So that told me a lot about the caliber. So again, the standard's been set pretty high for you. Now, that's not what I'm talking about. I just want to say a few introductory comments. Congratulating you, but don't let it go to your head, please. And you're going to get a lot of information this week. I've actually been fed tremendously this morning and last night, both. I have up here Psalm 19:1. You might imagine to an astronomer, as a Christian and a creationist, that's a very key verse. Always has been for me. the other important functions. There's a function here given. The skies proclaim God's handiwork. And I liked the introduction last night when you were told, you didn't come here to have fun, but you will anyway. And you didn't come here to hear great talks, but you will anyway. And he got down and talked about the fact that we're here to glorify God. And, even the creation can glorify God. It's very easy to lose sight of that. I do a lot of hiking in a place called Red River Gorge. Anybody heard of it or been there? My favorite place in the world, beautiful sandstone arches. And I go down there just look at the wonder and beauty. But, most people don't get any farther past than that. They don't see the Creator in this. And the same is true in astronomy. It's a wonderful tool that was told here in Psalm 19 about declaring and proclaiming God's glory. But, most people never get there. They see the pretty pictures. They might even know a little bit about the science involved. But that entirely misses the point as far as it goes. So you'd think that would be showing photographs would be a good way of illustrating this. In fact, the topic I'm doing today is astrophotography. And you may be able to figure that out from the two parts, astro and photography. But I'll put them together for you. It's basically photography of stars and other celestial objects. And I must say, I only got into this about 5, maybe 6 years ago. Part of the problem I had was I've been doing astronomy for a half century, but when I got started, I didn't have the proper equipment. And back then, it was all done on emulsions, that is on film. Anybody, young people, taking any film photographs? I understand it's making a comeback, believe it or not. I found that surprising. I bought my first digital camera 15 years ago, wore that thing out. I finally killed it, and I'm not going to tell you how. If you want to know, I'll let you know. But it was just a bridge camera, but had an incredible zoom on it, and I kept getting in situations where I wish I had an SLR, single lens reflex. That's what you really need to do astronomy. And so my next camera is going to be that. So when it died, I went out and got a digital SLR, and you can attach those to telescopes. What you do is you unscrew the camera lens. If you don't have the ability to take the lens off, you're kind of stuck on that one. And then a special attachment, you put it onto the telescope, and you're using the mirror or the lens of the telescope as your camera lens. So the two go-to telescopes I've been using is a 3.5-inch Questar, so it's got a lens about this big. And I showed sunspots to people yesterday through that Questar telescope. It's a really remarkable telescope. It also has a remarkable telephoto lens. It has a 1,300 millimeter focal length. So it's a whale of a telephoto lens. But I'll tell you a little more about another one I use, a 5-inch refractor. And I'll mention a little bit about that a little later on in my presentation. But I never really got around to it. I think I saved a lot of time and a lot of money by not getting into doing film. One of the disadvantages of film is that you can't see what you're doing until you get it processed. You get it back a week later and you figure out what you did wrong. And that's a very, very low angle learning curve. One of the things I love about this digital age is the fact that I can instantly see what the picture looks like, and then I can fix the problem. Oh, the exposure's too little or too much. I can fix that rather than waiting a week and then trying all over again. So it's really quite a boon here. Oh, this is one of my attempts. I did this at a summer camp I've been going to over Labor Day in Arizona. It's at 8,300 feet elevation. So it's very high, it's very dry, and so it's very dark also. It's about 300 miles to Albuquerque, I think, and about that far to Phoenix. So it's very dark. And what I did here is a half-an-hour exposure, and I didn't use a telescope for these. A lot of them I'm going to show you this morning. I didn't use a telescope. I put a regular camera lens, unzoomed. Then later on, I got a wide-angle lens, which gives me more width as well. So you can do some beautiful things. This is a half-hour exposure. Had set it on a tripod, and you see there's a star near the middle of this. Anybody know what star that is? Polaris, aka the North Star. It's not exactly at the middle, but the Earth's rotation axis is pointing within about 3/4 of a degree. So if you take a telescope and look at it, you can get these arcs, and I've done that. You can get a nice little arc in the telescope because you're magnifying it tremendously. This is with a low magnification, so Polaris, even though it's a small arc, is going to look like a dot on this scale. And as you get farther out, of course, the trails are longer, and this is caused by the Earth's rotation. Now, I did this photograph, and I got it down and looked at it a few times, started using it. It wasn't until about a month later I noticed something that I totally escaped before. I don't know why, it's pretty obvious. You notice along the northern horizon there, it's kind of red. Above that's kind of green. Do you all see that? Anybody know what that is? That's an aurora, northern lights. And it was not bright enough to be seen, but in a half hour you're going to pick it up. And that green and the red are caused by different elements, oxygen primarily in the upper atmosphere of the Earth. Again, I didn't notice that at first, and it wasn't noticeable that evening. By the way, the smear of light across the top, that's the Milky Way. And I'll be showing you more photographs of that as we go through this. Now, I started this about 3 years ago. This is my second attempt at doing a time-lapse photography. This is in my house above. In fact, that's the point of my house over my front door in northern Kentucky at suburban Cincinnati. So we've got a major airport nearby and a bunch of other things nearby. So even though it's pretty bright there, you can do things. The North Star, I arranged this so it's that star right above the point of the house. If you look to the upper left, what do you see? The Big Dipper, all right. Do you know how to use the Big Dipper to find the North Star? Look at the end of the bowl. You got two stars. You connect those, and they point to the North Star roughly. And above that, going from the North Star upward, there's a little dipper. I'm not going to try to point it out to you. It's a little difficult in this photograph. And what I did is I took about I think about 150 photographs over about a little over an hour, and then I put them into a time-lapse video. I've kind of gotten into that. Remember that smear I showed you, the stars all spinning around? Well, now we're going to see it actually move, so let's go ahead and hit the forward button on that, and then there you go. There's little flashes of light or airplanes passing by. There is an airport nearby, after all. Isn't that pretty cool? So it shows you what I did before, but you get a little time lapse to do that. Now, this is my second attempt. My first attempt, I should have done this at home before I tried this on the road, but the second attempt, well, actually, this is probably my third attempt I'm showing you here. I'll get the first attempt in a minute. If you look to the north, you saw the stars spin around. If you look to the south, they do something like this. Now, those little red flashes you see, those are from people in a campsite nearby, and the green light is me messing around with my laser pointer. That bright star there is Jupiter, and of course, that big smear of light coming through is the Milky Way. I took this, how many people have been to the Creation Museum or the Ark Encounter? You all know about Ken Ham and Answers in Genesis. You may think that working there is just a bowl full of cherries, but there actually are some very extreme conditions. The working conditions there can be quite harsh, I'm sorry to report. For instance, you would not believe what they make me do every year. Every summer, they make me take a week-long raft trip in Grand Canyon. The inhumanity of it all. I have to sleep on a cot outside. How bad is that for an astronomer? So every morning I wake up and I remind myself that I'm working today, so don't have too much fun while you're here. And these trips, we have geology by day and astronomy by night, and I add to that if I can keep people awake, because usually they're wiped out at the end of the day. I'm jazzed when I'm there. I'm usually the last to go to bed and the first to get up. I get about 4 hours a night, but when I'm out there, I'm just living on adrenaline. I figure I can sleep when I go back to work the next week, So if you want to go on one of these trips, it's a trip of a lifetime. I get to do every year. You really need to plan ahead. If you want to go in 2023, what you need to do is get on the waiting list for 2022. And then when they announce the 2023 schedule next year, they'll go to you first and give you an opportunity. So it takes 2 years of planning to get on these trips anymore. That's looking through the canyon walls and the inner gorge early on in the trip, technically in Marble Canyon. And I'm going to run this again. I want you to kind of contrast it to the first one I showed you. All right? Now, do you notice anything different from this than the other one? One of them is pretty obvious. Yes? Okay, it's moving left to right. You're not seeing the center, are you? But can you see it's moving faster on the top and slower on the bottom? That's because there's a spot in the northern part of the sky we can see where the axis is pointing towards the North Star. But the other side of that axis is 180 degrees away, and it's well below the horizon. It would be down here somewhere. All right, so it's well below that point. The angle that rotation point makes with your northern horizon is equal to your latitude. So the higher you go, the higher in the sky you go. I was in Edinburgh about a year and a half ago, and I was amazed how high in the sky the North Star was. I'd never seen it that high before. Okay, so the appearance is different, the angle's different, but what else? There's something else going on. Yeah.
It seems to move faster.
Okay, it's because it's farther away. Yeah. Anything else you noticed? Very good. That's what I was looking for. That's the most obvious one. You kind of trip over it. Things here are moving clockwise, aren't they? And the ones in the other direction are moving counterclockwise. They're both moving in the same direction, east to west. It's just if you look this way, it's going to go one direction. It's going to go like that. If you look this direction, it's still going the same direction, but you flipped around. So it looks reversed. So when you look to the south, it goes clockwise. You look to the north, it goes counterclockwise. Well, by the way, this is a still from the sequence I did. You lose something when you do the time lapse. This is a still from the original. And Jupiter again on the right there. Not my best Milky Way photo, though. Okay, now my first attempt, and again I should have done this before I went on the road, is from South Africa. I was there a year and a half ago, 2 years ago now, I guess. And we went to Kruger National Park. You ever heard of Kruger National Park? It's a world-famous national park, and you might think, well, it's like our national parks. You go to Grand Canyon, what do? Well, you drive, you get out of your car, you look at stuff, you get in your car, you drive, you get out of you know the routine. The Smokies are the same way. Well, you don't do that in Kruger. You stay in your car. Anybody know why? Yeah. Yeah, if you get out of your car, you may not notice that lion in the brush next to the car. So there are a few places you can get out. One of them is on a bridge. One place we went to is a bridge across a river. They got a stripe on either, a line on either side. They figure on the bridge, lions can't hide from you very well there. And you get on the bridge, you can get out and look over and see hippos and crocodiles and stuff down in the river. But you have to stay between those two lines. And then I tell people, I looked it up. Kruger National Park is the size of New Jersey. But I figured it's not nearly as dangerous as New Jersey. So, anybody from the Garden State here? Good. We all like to make fun of New Jersey, don't we? You know, California has more attorneys than any other state, and New Jersey has more toxic waste dumps than any other state. You know why? New Jersey got first pick. Ooh, not as many people laughing at that one. Your father must be an attorney, I guess. Anyway, this is in Kruger National Park. And by the way, I could get out of my car here because they have these little enclosures, campgrounds. They have little cabins we stayed in. You have to reserve ahead of time. And you have to get there before 6 p.m. because that's when they close the gates. And you can't leave until 6 a.m. when they open the gates again. At night, we're walking around. You can hear hyenas and hippos down on the river. But the fence is so high, nothing can get in to get you there. So it's perfectly safe. So I went out. It was partly cloudy that night. Had to dodge clouds. We also had a bright moon. And I'm in a parking lot. And even though it's dark sky, we had some bright moon that night, which kind of mimics the city lights. And I had a few cars turning around in this parking lot. This is about a little over 2 hours of time lapse. That band of light to the left is the Milky Way. If you look to the right of center in the middle, there's a little fuzzy patch. Y'all see that? That's called the Large Magellanic Cloud. It's a satellite galaxy of our own Milky Way galaxy. Faulkner's rule of observing number 2 is you can't see it from this latitude, so you have to go to South America to see it. And then farther down, there's another fuzz patch near the bottom. That's a small Magellanic Cloud. They're really cool, but you have to go well south to see them. You can't see them this far north. And what I want you to notice when I play this time lapse is the stars, as before, are going to be going clockwise. Remember, you're looking the other direction now, like I was looking in Grand Canyon. But now, since you're in the southern hemisphere, that center of rotation is going to be above the horizon. It's going to be a little near the center, maybe a little right of center, and kind of low. You'll see that. But notice there is no south star. There is no bright star close to the south celestial pole, so finding it's a little tricky. Over on the left is the Southern Cross. It's right above where I'm pointing up there. You see those 4 stars? That's the Southern Cross. And if you take a long axis of that to the right, it will point roughly to where the south celestial pole is, that point in the sky. No more ado, I will do the rotation for you. and then some clouds will roll in here at the end. So again, I like time-lapse photography. It's really, really cool, and I'm getting better at it. I've learned a few tricks, and I continue to do this, and I will do some more this summer when I go back to Grand Canyon, back to Arizona in September. All right. You know, I look at the Milky Way. It's a collection of a few 100 billion stars, and that's only one of a few 100 billion galaxies. I'll let you figure out the math on that and how many stars there are. Naked eye, you can see a few thousand stars. Telescopes, of course, the sky literally is the limit on this. And when I contemplate those numbers, I think of Psalm 147:4, that it says he determines the number of stars and he gives to all of them their names. Think about that. We've got proper names for a couple hundred stars. We have catalog names for a few million stars, you know, like something GSC 4872-173. That's not a name, that's a catalog entry. But you know, the Lord, it says, he names all of them. He knows how many there are. He can count them. We can't count them, but he can. And he gives names to all of them. And I suspect those names are very descriptive. Names mean something to the Lord. If you look in the Old Testament particularly, someone says something, this is called that. Many times they give you the reason because in the Hebrew it actually is descriptive of that person or that place. I think the stars are probably the same way. That's baffling to me. That's boggling to me, I should say. It's beyond what I can comprehend. But hey, if you create the universe, counting and naming the stars is a pretty trivial matter by comparison, is it not? And that's one of the things I think that impresses me about astronomy, the beauty and the wonder, but also the vastness of everything and how incredibly tiny we are. One of the speakers already is quoted from Psalm 8, though. When I look up the heavens, see your things you've made with your fingers, what is man that you are mindful of him? Well, there's an important answer to that one. It's because we're created in God's image and we're crowned with glory and honor. He's made us very special. I got up a little later that morning. That was at night. Clouds kind of rolled through. That early that morning I went out. I wanted to get the center of the Milky Way. Unfortunately, I have a few clouds to the lower left, but that fat portion of the Milky Way there you see is the center of our galaxy. And it gets high overhead in the southern hemisphere. And the northern hemisphere never gets really high above the horizon. I've tried to shoot it from northern hemisphere, but not too well. Everything to the left side of this is not visible to us. Okay, this is one of probably my best Milky Way photo. I took this at the camp in 8,300 feet in Arizona. And you can see a bit of that bulge off to the right there. And then dark lanes in the Milky Way caused by dust clouds that obscure light from more distant objects. The combined light that you see there is the faint light is a combined light of millions of stars that are too faint to be seen individually. How many of you have seen the Milky Way in a really dark sky? Okay, it's an impressive thing, I think you would agree. And one of my favorite activities is just to take binoculars and scan along that. The stuff you can see with binoculars in a dark sky is remarkable. Sometimes in these raft trips and stuff, I'll just have my binoculars and tell them, just spend some time. They'll spend 20 minutes just looking at stuff, have no idea what they're looking at, but they really enjoy it. There are star clusters and nebulae. It's a remarkable sight. And this is another one I took a few years ago. This is probably going on 3 years, but it must have been 3 summers ago. That's showing the Milky Way peeking around the edge of a rock face there. That bright star to the left of it, that is Mars. It was very bright and close to us back in 2018, I think it was, 2017, one of those two. All right. So again, I'm going to quote here from Isaiah 40:26. Lift up your eyes on high and see. Who created these? He who brings out their host by number, calling them all by name. Once again, numbering them and naming them. By the greatness of his might, and because he is strong in power, not one is missing. This reminds me in the New Testament, in Colossians 1:16, also in Hebrews 1:3, it speaks of the sustaining of this creation by the power of God's word. We have the creation taking place over 6 days. Very miraculous things going on during that creation week. And then after that, God is sustaining by the power of his will. And he does that in a consistent manner. And this was an insight that came about through the Reformation. Science blossomed in the 17th century in Protestant Europe. And I don't think it's a coincidence at all. In fact, even some critics and some atheists and agnostics have commented much the same way. Throughout the Middle Ages, the Roman Catholic Church had adopted some pagan ideas from the Greeks, and one of them was a separation between the heavenly realm and the earthly realm. The Greeks taught that things were different on the earth from in the heavenly realm above, and so the motions of the heavenly bodies, the sun, the moon, the stars, the planets, fundamentally different from the motions on the earth. But the Protestant Reformation, one of the things it did is it tore down the separation between the heavenly realm and the terrestrial realm, because part of that teaching the Roman Catholic Church taught was that the priest and king were doing the Lord's work, but anybody else, well, you just weren't doing enough. You weren't doing God's work. You were doing venal labor here. The Protestant Reformation tore that separation down and said, no, if you're called to be a farmer, then be a farmer to God's glory, because that's exactly what you're doing. If you're called to do that, you better not become the priest or the king, because that's not your calling. There's holiness and there's virtue and goodness in good, honest work. This gave rise to what we call the Protestant work ethic. I heard that term growing up, and I didn't understand it until many, many years later when I learned how that came about. And this same sort of thing splashed over into the physical realm as well. Even though it's tainted by the effects of man's sin, there's some dignity and honor to the creation around us and the heavens above us. Furthermore, it's not as separated as you might think. And this working hypothesis people developed 4 centuries, 5 centuries ago, that the heavenly realm, the stars, the planet, the astronomical realm, maybe I should say, follows the same basic rules that we find here on the earth. And that's the working hypothesis that Sir Isaac Newton used to develop his physics as we know it, and many other people as well. So we have that because God is a God of order and a God of decrees, and he does things in a consistent pattern. You see a little bit of his character is imprinted upon the creation by the way he sustains that creation. And that makes science possible, because to the ancient world mind, even the medieval worldview, things were just stochastic. They were just changing all the time, and there's no predictability, no regularity. But the Protestant Reformation changed the way people looked at things. They said, I think the world is knowable because God is knowable. And science blossomed and took off. Had about a 75-year window there before the so-called Enlightenment came along and wiped that out. I got a good 3-part alliteration sermon there. The 3 greatest disasters to befall humanity: the fall, the flood, and France. and the Enlightenment was a disaster, and it very quickly began to appropriate science, which was a God-honoring thing originally, and by the 19th century, God became less and less welcome in the scientific arena. We creation scientists are trying to retake that ground and reestablish the true foundation of science. It's gotten to the point now that many scientists are baffled. They look up at the world and they say, wow, look at all the order we see. And one scientist was quoted as saying, the most incomprehensible thing about the world is that it's comprehensible. And I think if Sir Isaac were alive today, he'd slap him upside of the head and say, of course, you dolt. God made it that way. And the reason why he makes it that way, again, is because he sustains it that way. We sometimes think that the norm is the sustaining. Physics, as we know it, is describing this regularity, this pattern. We think that's the norm. But think about this, the real breakthrough for me a few years ago when I realized this. Remember, if you understand that God is sustaining the world by the power of his word, then moment by moment, that is a miracle too, isn't it? And what would happen if God stopped sustaining the world for just an instant? I hate to contemplate, but I think it would cease to exist. Okay, it's just the way it is. He has to maintain that, and he does it in an orderly way. That's another talk, another time perhaps. All right, and then it says in the Genesis day 4 account, by the way, I'm a little embarrassed sometimes, but I'll share it with people. I'm a really, really ardent 6-day creationist, and I really like the 4th day because that's when God made the heavenly realm, the astronomical realm. I don't think they're very popular anymore, but back 15, 20 years ago, there was a popular Christian band called Third Day. Y'all heard of that? Are they still around? They still perform, I guess? I must confess, when I first heard the name of that band, I totally misunderstood. My response was, what, they groove out on dry land and plants? Somebody actually had to explain that to me. Oh, he rose on the third day. Okay. So if I started a band, what would the name be? Fourth Day. Anybody ready to join my band? Nobody? Well, you have to understand what instrument I play. Anybody play an orchestra? Okay, I play viola. You know about viola jokes, right? All right, okay. Just making sure. I love to make fun of the viola. It's a fun instrument to play and make fun of at the same time. What's perfect pitch? When you throw an accordion into a dumpster and it lands on a viola. I digress. Let's get back to day 4, my favorite day of the creation week. God made 2 great lights, the greater light to rule the day. And obviously that's the sun. That's what we call it, okay? That's the first part of Genesis 1:16. So here I have a photograph of the sun. I took this. This is my first telescope picture I'm showing you this morning. And this is a photograph of the sun I took a few years ago. Who looked through this telescope yesterday and saw the sunspots? Were they anything like this? No, they were a lot smaller. These are monster spots. People see these and think, well, they're not that big. Well, I'll show you the next picture, okay? We have photoshopped in this the Earth for comparison. The diameter of the sun is 109 times that of the Earth. So I was showing people yesterday these little bitty spots, and they didn't look very impressive to most people. I said, but you got to consider they're bigger than the Earth is. They're probably the size of the Earth. So this is back a few years ago when we still had sunspots. We've gone through minimum now. We're starting to come back up on the upside. But you can see the structure there. The inner portion's kind of dark, and the outer portion's kind of grayish. These are cooler regions on the sun. They're regions of intense magnetic activity. They go through an 11-year cycle. There's a lot we know about sunspots. There's a lot we don't know about sunspots, like, for instance, why there's an 11-year cycle. We can kind of describe it. We don't know really what's causing that magnetic field inside the sun. So sunspots are interesting. If it were clear at all today, I could set up the telescope and show you again this afternoon, this morning, if it clears up. It's supposed to be cloudy much of the week, I'm afraid, though. Okay, again, these were 2 different photographs I took, and we photoshopped one in there. Now, we also know from the second part of verse 16 that he made the lesser light to rule the night, and that is, of course, the moon. All right, the moon is, we take it for granted many times. I took this photograph through the Quest Star a few years ago. I was pretty impressed with it. It shows you a first quarter moon. I'm still trying to figure out how I can make it a bit sharper. And one of the little tricks I found is to get a different telescope. And there's a 5-inch refractor that I use. I told you about a little thing that helps me out here. For Christmas, I asked my wife to get me a little device that goes onto this that will extend the focal length by a factor of 4. Remember I said the Quest Star had a focal length of 1,300 millimeters? Well, with this little device put on the telescope, this 5-inch refractor has a focal length of about 2,450 millimeters. So that's the giant telephoto lens. And so I didn't have a whole lot of opportunities early part of the year to use it, but I did recently go out and shoot another first quarter photograph, and there's my endeavor there. And you can see it's a lot sharper than that other one was. And then I zoomed in on the, what I did is I just cropped. By the way, these are reproduced at the same scale of the original. This is how big it was in the original. This is how big it is in the original. So it's nearly twice as the scale because of the much larger telescope. I can't get the whole moon in. I can, in this other telescope now, I can get it in the Quest Star, but not this one. But I can get, say, a quarter phase in all of it by using the landscape mode as I have there. I zoomed in on the left, cropped it, and made this photograph, again showing much more detail. This is my best lunar photograph so far. As it turns out, photography is an art. There's a lot of little tricks you can learn. Over the past 5 years or so, I've learned a lot of tricks, and I continue to learn tricks to do this. One thing I wanted to use this device for was to photograph the planets. They're very tiny, and so getting a big plate scale is difficult. I did this one a few weeks ago. This is Jupiter. You can see a couple of dark bands. I did crop this and then blow it up because on the original it's very small still. And I'm thinking about investing in another special camera to go on the telescope to get this even better. But that's Jupiter. Now, one of the weird things about the planets is our eyes respond very differently than the way the camera does. When you look through the telescope at Jupiter, it looks a lot like that, but you'll also see the 4 Galilean satellites, or moons that it has. We're calling them the Galilean satellites because Galileo was the one who discovered them 4 centuries ago. You don't see it in this photograph. There's a reason for that. Our eyes respond to light logarithmically. What that does is it compresses differences. So you can see really bright things and really faint things at the same time. And the cameras don't do that. They respond linearly. If you have twice as much light, you get twice the response. Your eyes, you may get 15 or 20% more response. It's called dynamic range. Our eyes are remarkably designed things. They're not adapted, they're designed. And one of the functions here is it allows you to be in here in relatively dim lighting. If we turned all the lights off in here, just had like the exit lights on, you'd be, after a few moments, you could see well enough to get out of here if you had to. But then when you walk outside, you're not blinded by the bright light out there. We can make devices that can measure very low light levels, but they will be destroyed by exposure to sunlight. We can make things that can measure sunlight, but they'll be blind as a bat in here. And our eyes are able to adapt to that because that's the way they're designed to do that. Isn't God a wonderful designer? We can't make a device like that, but God does. Our hearing is the same way. You ever noticed that if you put out a recorder, just set it out and you record what's going on in a room, does it faithfully record what happened? Not at all. If somebody's up close or somebody bumps the table up close, it picks that up pretty well, but if you're some distance back, it's just barely audible. I used to illustrate to my students this way. I would come up to somebody about this far from their face, and I would scream in their face. They didn't like that. And I asked them, if you ever scream in a recorder? Of course you did. First time I got a recorder, I was like 12 years old. That's what I did. I screamed in it. And when you do that, what do you hear when you play it back? Well, you can't hear a thing. I can scream in your face and you can hear me. You won't like it, but you can understand me. But by the way, if you sit across the room and whisper like this, can everybody hear me? Raise your hand if you can hear me. Well, every hand goes up, good. But if you got a recorder sitting in front of you, you wouldn't be able to hear me at all, would you? That's, again, design coming in. Well, what I can do is I can take a short exposure, which I did here, or I can take a long exposure, which I did there. You can see the 4 Galilean satellites lined up. I looked them up here. I can't remember which one's which. Ganymede, Io, Ganymede, Callisto, and Europa. I had to look them up. I can't recognize them. They're little spots like that. What's wrong with Jupiter? It's so overexposed you can't see the features. And again, cameras can get bits and pieces of what we see, but it can't record faithfully what our eyeballs see. Again, what a remarkable designer we have. Well, Saturn's not too far away from Jupiter, and so I took this photograph. Again, I've cropped it and expanded it, and that's close to what it looks like to the telescope. It looks better than that, actually, sharper. I need to keep working on this and working my tech. Not bad for a first attempt, okay? But I'm not satisfied. It's going to have to get better and better. And the same thing is true here. I can't see any of the satellites, but what if I take a longer exposure? Well, I overexpose it, and you can see it's kind of elongated shape. That's the overexposed Saturn. But I was able to identify 5 of its satellites, Titan, Rhea, Dione, Enceladus, and Tethys. And through that telescope, sometimes I can see 3, 4, or even all 5 of those. I don't know which one's which. I have to go look them up. Sky and Telescope magazine has a little program on their website that will allow you to enter the time, and it will tell you exactly what they are. I put the time in, the date, and just what I see there is what I saw. It's easy as pie to get those all lined up. Again, with the eye, all of it, but not with photographs. I took this 3 years ago during a total lunar eclipse we had. This is about a 12-second exposure, and it's taken through the Quest star. There's a star to the upper left. Might be a couple others in the background there too. The center of the Earth's shadow is down near the bottom of the moon. That's why it's darkest there. It's not totally dark because the Earth's atmosphere has, it refracts and bends light. Like you see a sunset, it looks red for that reason, because it scatters out blue light and red light is transmitted. And that's what you see during a lunar eclipse. They tend to be reddish, I think usually kind of an orange, pumpkin color, sometimes copper. I think this one was more of a copper color. A very beautiful thing. I've never seen people have taken to calling these blood moons, which I object to. It's only been around for about 10 years calling it that. I've seen a dozen or more total lunar eclipses, and not one of them would I describe as being blood-colored. Usually it's pumpkin or orange or copper-colored. Now, this is blown up. This was the full size frame of the picture I took through the telescope. I shrank one of them down in the partial phase. This is about 45 minutes before totality, I guess, half an hour before totality. And you can see the moon moving from upper right to lower left, entering the Earth's shadow. I'm going to talk about this evening, but I'll give you a little presage here. What shape do you notice the Earth's shadow is? It's curved. More particularly, how is it curved? Can you tell by the section you're seeing? Well, this is taken about an hour and a half later, maybe 2 hours later, and the partial phase ending. Now do you get an idea what it looks like? Okay, if you're kind of slow, I'll draw it in for you. All right? Got an ah back there. Okay. The Earth's shadow is indeed a circle. I've looked at, again, a dozen or more total lunar eclipses plus a bunch of partials, and it always has that shape. What's the only shape, regardless of its orientation, will cast a round shadow? A sphere. Yeah. I'll talk more about that tonight. Just a little heads up on that one. Okay, I also noticed back in the eclipse 3 years ago that the moon looked awful big in the telescope, so I looked it up, and the moon that night was very close to perigee. People don't realize this, but the moon's orbit is not a circle, it's an ellipse. It doesn't deviate much from a circle, but its distance from us changes by about 14%. Perigee is the closest point, and apogee is the most distant point. Well, to be a lunar eclipse, you have to have a full moon, and that full moon was within a day or so of perigee. That's why it looked a little larger than I was used to seeing through the telescope. So I looked it up on the calendar, and 9 months later, in September that year, the moon was once again at apogee. So 9 months later, I took a picture of the moon at full moon, and you can see that it's brighter, and it's not got that reddish color, more of a white. This is a very short exposure. This is like probably 400th of a second as opposed to 12 seconds, because the light level is still very different. And I didn't doctor these photos at all. I reproduced them. I had to shrink them down a little bit, but I shrunk them by the same amount, so they are reproduced at the same scale. And can you see the difference in size between the two? Yeah, it's pretty obvious. I printed them out and measured them, and of course calculated it was a 14% difference from one to the other. Now, you sometimes hear about these supermoons. There was one just last week during an eclipse. That gets a lot of hype. People think when they hear a supermoon, it's going to appear larger than usual. They expect to go outside and see this big gargantuan thing in the sky, and they, oh, that little thing? And the problem is, as good as the eye is, it's not good at remembering things too well. And so when you look at the moon and you come back 9 months later, it's your eyes are just going to your mind's going to kind of compensate for it. Plus, bright objects in the sky look larger than they are, and things near the horizon look larger than they are. So we can be fooled very easily. The camera cannot. That's one of the things the camera has over the human eye, is the fact that it's more difficult to fool. It's going to record the size faithfully and make a permanent record that you don't have to keep around inside your brain all this time. Okay, Scripture makes a comparison in Psalm 89:37. He's talking about the covenant established. He says, like the moon, it shall be established forever, a faithful witness in the skies. So the moon, God is saying to Israel, is saying, look, here I have this sign of this covenant, as you were. Not quite a strong, powerful statement like the rainbow was in the Noahic covenant in the book of Genesis, however. Okay, this is a photograph of a meteor. I took this, this is one of my first astrophotos, probably 6 years ago. I set my camera up. This is on my back deck of my house with the light pollution and everything. There's also a little bit of clouds at night. This is the Perseid meteor shower, one of the nicest meteor showers of the year. It's August. early mid-August, and so it's a fine time for many, many people. And I hadn't been taking too many photographs when I saw one, and I thought, I wonder if I captured that one. It wasn't until after I took a bunch of photos that I downloaded it, and sure enough that I did. It came from lower left to upper right, so it was climbing upward because that's the direction the radiant was with the shower. It wasn't after I looked at the photo for a moment, I saw this other little streak to the upper left. You see that? That's a satellite moving across there, and that was a little bonus that I picked up taking this photograph. Well, sometimes my raft trip is in early mid-August, and so this is one I took a couple of summers ago on a trip. That little streak, this is the wide-angle lens, so the path is not nearly as long. You can see it on the lower right, there's a meteor over there. If you look near the middle, maybe a little left of center, but just barely, there's a little smudge, that faint smudge of light. You all see that? That's the Andromeda Galaxy, normally the most distant object that you can see with the naked eye. As it turns out on the original, there are other little faint things that you can pick up as well. So I'm really happy about this. I think this is a 25-second exposure at ISO 6400. I discovered there's another ISO setting I didn't know about. I can double it up to 12,800, so when I go back this summer, I'm going to be using that one to see what I can see. Okay, this is another Perseid Meteor I took last summer, and you can see the canyon wall. This is the last night of our trip, and a little bit of the Milky Way, and that's a Perseid Meteor there. This is the next morning we were going to be helicoptered out for the end of our trip. And actually what I was doing here was trying to do two things. I was trying to capture meteor photographs, but I wanted to make another time lapse. I'm going to show you the time lapse right now, and toward the end you will see that little streak if you pay attention. Okay, let's go. Ready? If you blink, you miss it. I may have blinked. There we go. Oh, that's not there. Now sunrise is going to start to happen. Dawn's going to happen. The other things are streaks are planes. There you go. And we're going into dawn. I think that makes a nice transition, don't you think? All right. Last summer, I redid this. It's the same place. We camped, almost the same campsite, the first one, time-lapse I showed you. And I'll show this again. This is a different, we were actually upstream and on the other side of the river, I think. But the same, you can recognize that notch that the Colorado River flows through. And there goes the Milky Way. Now the moon is starting to come up. And look at that. Isn't that cool? Let me show that again. I like that. It starts off, it's dark, and then the moon, the waning gibbous moon starts to rise. The sky starts to brighten. That's your first clue. It starts to wash things out. And then moonlight starts to creep down the canyon wall. And I wish I could have gone farther, but I was already out there. It was 2 a.m. It was the first night I'd flown out. I was exhausted. So if I were more dedicated, I couldn't have gotten a few more out of this. And by the way, that's Jupiter, the bright star, and Saturn to the left of it, just barely coming above the rocks there. And then I took this in Arizona at the camp a few years ago. This is a little, if you look at the top, there are two meteors near the top. You see those in Orion, you may notice off to the right below those. And in Sirius is the bright star to the far right on the bottom. And right above the tree there, that's an airplane going through there. But what I want to show you here, the Milky Way comes from the middle top to the lower right, but then there's light coming up from that tree like that. You all see the light doing that? That's called the Zodiacal Light. It's caused by sunlight scattering off of dust particles in the plane of the Earth's orbit. And I had seen this a few times. You need a really dark sky and dry weather and good exposure. Certain times of year help. In the morning, it's best to look to the east in the autumn, beginning of September. It'd be in the west in the evening in March to maximize your ability to see it. But I had seen photographs years ago, back in the days of film that people had taken. I hadn't seen any digital ones done. So I thought, well, I'm going to try that since I'm in a prime location for it. And I'm really pleased with how well that turned out. But I was doing this over 2.5 hours. And so I'm going to take you into dawn on this one. But watch as it takes place. Things are rising in the east. The north celestial pole's off to the left. And as it does that, the zodiacal light will get more and more and more intense because you're getting closer to the sun. And about the time you think it's really getting good, then dawn happens, kind of wrecks it at that point. So here we go. And watch that intensity increase over there in the east. There it comes, more and more intense. And then bam, dawn takes place. I love that transition. You want to see that again? That's a cool. I love this photo. This image. At the time, I thought it was my best. I think that one with the rising moonlight in Grand Canyon is a little better. But the Zodiacal Light still rules, and I hope to repeat this again this September if the weather's good. I hope to get up if I can stay awake and do this. Back last year, we had Comet Neowise. It was a naked eye comet. I walked out my house several mornings, but I picked July 8th and July 13th. What I did is I took a photograph. There's a tree there, one of my neighbor's yards. I circled 2 stars up there on the July 8th, and I got an arrow pointing to the comet. You can see the tail sticking up like that. It tells you which direction the sun is. I went out 5 mornings later, and I did it at the exact same time. You can see the tree. I had to change my position a little bit, but you can see the same tree there. Those 2 stars are marked. Now they're higher in the sky. The reason why they're higher in the sky is it's 5 days later, and the stars rise 4 minutes earlier each day. So if I wanted to match what we call the sidereal time, I would have done this 20 minutes earlier. I did it, by Eastern Standard Time. So the thing is, you can see how much Comet Neowise moved. It was over there close to that lower star, and it moved several degrees rapidly from one morning to the next, and certainly over 5 days it was noticeable. I also made a time lapse one evening there. I'm not happy with this. A number of problems. Some clouds, some planes moving through, not entirely dark, and most importantly, I had to zoom in to get this, and I didn't think. I know better now. I should have used my remote, so I was advancing the film, advancing the camera each time, manually hitting the shutter, so it jumps around a lot. I apologize for that. If I had to do over again, it wouldn't do that, but you'll live and learn on this. So here goes the time lapse. Bounces around, but you can get the idea if it's going down. I take it all the way down. I change the exposure time, too, as I went through. It settles down towards the end, and there we go. So that's it. Then went back to camp back last September. And this one is interesting. I couldn't do my Zodiacal Light photos because we had a waning gibbous moon that rose pretty early. Remember what happened in Grand Canyon that time. And this one I started at dusk. And you can see the Milky Way a little bit there. It's going to get more intense. So looking south, so they're going to move from left to right. You can see Jupiter is a bright star. Saturn is the less bright to the left of it. And what happens here, I got to explain. I got a lot of stuff to look for. As things move off to the right, it's in dusk. The sky gets darker, and about the time it totally gets dark, the moon starts to rise. And so it starts to lighten up again like it did in Grand Canyon. But this time, the moonlight goes creeping down through the meadow there by the trees. It's kind of cool. And then, towards the end, there's a guy that works at the camp trying to get ready for summer camp, the weekend camp the night before. He's driving around with his headlights on his truck and with flashlights. It's kind of a neat effect. There are a bunch of things going on. It's a very busy sort of scene. But anyway, I like this. It starts getting dim. There you go. And it starts to lighten up again. And here comes the moonlight coming down. There's the guy running around. So, that's kind of a cool photo. So I've really gotten into time lapse. As I said, I really enjoy the fun I can have with it. I went to the total solar eclipse in 2017. Many of you live here in the southeast, and it went over. I already got a thumbs up here. Was that the coolest thing you've ever seen? It's incredible, isn't it? You hear descriptions, you see photographs, but when you're actually there, it's amazing what you can see. I've seen 2 total solar eclipses. I'm going to blow your mind. I didn't understand either until I got my second one. Every one of them's different. So there's another one coming in 2024. If you go to that one, be prepared to be blown away all over again. It's strange. Anyway, I was praying that the Lord would produce some sunspots for us because I'd seen photographs of a partially eclipsed sun and sunspots. And I didn't explain at the beginning the main motivation of why I started doing this. I need illustrations for some of the books I write, the articles I write, and things like that. And a lot of the good illustrations are copyrighted. You got to get permission, and a lot of times you're a creationist. No, we're not going to get permission for that. So I've been trying to build up a body of astrophotographs that we can use in our publications. Don't have to pay any royalties, don't have to get permission because there are photographs. That's been my main motivation. So I wanted one of this, and the Lord was kind. A few days out, I saw these sunspots blowing up, and I thought, this is great, Lord, thank you. And during the eclipse, I got a picture of the partially eclipsed sun and these sunspots on the sun. So the Lord's good, is he not? Here's one I took of the Questar during totality. You can see the inner corona, and you can see some of those prominences out on the edges. Again, there's some friends of mine who did better photographs than this. I won't show you those. I'll tell you about them in just a moment here. But beautiful, beautiful thing. And again, if you think it looked just like that, it didn't. It looked better than that because the prominences you see are pretty bright and the corona is pretty faint. If I take a short exposure, I get the prominences, but I don't get the corona. If I take a longer exposure, I overexpose the prominences, but I get the corona. This is kind of a midpoint in between, getting the best I can. But the eye could see it all. Just like you could see the Jupiter well and Saturn well and see its satellites or moons pretty well. This actually goes back to film days. I took this in 1979 at my first eclipse, total solar eclipse. That's right at the end. It's called the diamond ring effect. And I may be partial, but I think it's one of the best photographs I've ever seen of a diamond ring effect. I think it's really cool. And I warned everybody at the 2017 eclipse. I told them when to stop looking and found out later, because it's unsafe to look at that little bit coming through. I found out later both my son and my wife said they saw this with the naked eye. I said, "Are you out of your mind?" I was envious, though, because their vision seems to be okay, and they saw it, and I didn't. So I'm not a gambler, though, so I'm not going to do that. All right. I'll close with this. There's a man named Tom Vail. He was a river rat. He took a job in the mid-'80s, left the high-pressure world of programming, was burned out. He took a river raft trip and was hooked. Spoon was hired on in staff and spent the next 20 years leading raft trips in Grand Canyon. That was his job. Imagine a job like that, almost as good as my job. And he was not a believer, but one woman came on his trip, and she was a believer, and she started asking him questions. Questions he couldn't answer, and questions he began thinking about. You know, those kind of thought-provoking things you have at a worldview conference like this. Eventually, he became a creationist, and then he became a Christian pretty quickly after that. I know several people that were You ever known people who have been creationists first and then became Christians? That's amazing. It works out that way. That's not the way it usually works, but sometimes the Lord works that way. And so then he changed his whole attitude. He wanted to share the wonder of Grand Canyon, but also the story behind it of catastrophism during the flood. So much so that he eventually started a ministry called Canyon Ministries. We partner with them to do our trips. We have a cooperative effort there. They also do rim tours. If you want to go to Grand Canyon, you want to see the rim, and you want to see it from a creationary Christian perspective, book with Canyon Ministries. I've done the trip myself with them, and I was very pleased, and you will be too. Anyway, Tom Vail, about 15 years ago, put together this book, a coffee table book called Grand Canyon, A Different View. It's got these beautiful photos of Grand Canyon he and other people have taken, and he wrote some essays, and other people, you see the list of authors there on the right wrote essays as well, brief essays, to see what you're looking at, tell what you're looking at there. Well, about 5-6 years ago, Georgia Purdom, a biologist on staff at Answers in Genesis, she too led a trip to the Galapagos Islands. You know, heard of the Galapagos Islands, right? The evolutionists love to talk about the Galapagos, just like the evolutionists love to talk about Grand Canyon. But as it turns out, we have a story ourselves of the Grand Canyon and Galapagos. So she wrote she put together this book of many photographs of the Galapagos with essays from various creation scientists. You see where this is going? Fourth quarter of this year, we hope to publish The Heavens, A Different View. And what I have done here is taken over 100 photographs, some of which I've taken, but actually most of them taken by two amateur astronomers who are Christians or creationists. They love Answers in Genesis, and they were thrilled that their photographs would be part of this. One difference in this one is I wrote all the essays in this one instead of a whole panel of people. And again, it's being put together by Master Books, and it should be available fourth quarter of this year. Great Christmas gift ideas. I plan to give a bunch of these away this year to friends and family as well, along with a calendar I started doing last year. So I'll leave that with you. Thank you for your attention. I will see you again this afternoon.
Okay, we have a half an hour break, so feel free to look at the book table and just take a break. See you in 30 minutes.